Hello friends, so in today's class we will solve one numerical on psychrometry chapter, and here we will use a psychrometric chart and we'll solve the numericals. So in the previous some video lectures we solved two or three numericals. There we are without using psychrometric chart, we solved using some equations, we solved some numericals. So here with the use of psychrometric chart we are going to solve one numerical. Now this is the definition of the numerical. So an air conditioning system, so this is one of the important problem which I have taken from previous year question paper, and it is asked for 8 marks. So this is the definition of the problem. We will read it now. An air conditioning system is designed under the following conditions. Outdoor conditions, the temperature is 30 degrees Celsius, that is dry bulb temperature, and 75% relative humidity. And required indoor conditions, 22 degrees Celsius dry bulb temperature and 70% relative humidity. So first condition, this outdoor condition, it is atmospheric air condition. This is outside. So in these two conditions, the person or the human is uncomfortable. He is not comfortable inside the room. So the temperature of the air inside the room should be dry bulb temperature of 22 degree and 70% of relative humidity. This condition should be required. It is called required indoor condition, that is room conditions. So to achieve this condition, the amount of free air circulated should be inside the room is 3 meter cube per second, and the amount of or volume of air circulated inside the room is 3 meter cube per second. And one data is given: cold dew point temperature 14 degrees Celsius. So what is dew point temperature? The temperature at which the water vapor condensed to liquid. So to achieve this condition from outdoor to indoor conditions, the required condition is achieved first by cooling and dehumidification and then by heating. So these are the three processes here given. We have to follow these process only. We can achieve, there are other way to solve this problem, but we cannot use those conditions. Here specifically he has mentioned cooling first you have to do, second one is dehumidification, and then by heating. So once parallelly you cannot do all three. So sequence order you have to follow: cooling first, dehumidification first, and heating is the third process. So in these three conditions he has asked some three unknowns. Calculate first one, the capacity of the cooling coil. If you are using cooling process, then obviously you must be using some cooling coils. So how much capacity of cooling coil is required in tons you need to calculate. Tons is nothing but is not mass or unit, it is TOR, that is tons of refrigeration. In the elements of mechanical engineering course you have discussed or you have studied tons of refrigeration is a unit of refrigerating effect. Understood? So the cooling coil capacity you need to convert in tons of TOR, that is tons of refrigeration, or in short form it is also called tons. And capacity of heating coil is also asked, because the third process is heating. So heating indicates the rise in temperature. So how much amount of heat you need to supply to the air, that is the reason he has asked capacity of the heating coil. And the third one is amount of water vapor removed. Amount of water vapor removed, it is related to dehumidification process. So dehumidification process nothing but the removal or extraction of water from the moist air. So that is called how much amount of water vapor you remove to achieve outdoor conditions to indoor conditions. So this is the definition of the problem. So we will write step number 1, given data. So using psychrometric chart you are solving the problem. So first I will write step number 1, given data. In the data he has given volume of air circulated inside the room, so 3.33 meter cube per second. In the previous problem we solved one problem, a numerical. In that he has given volume of air circulated in terms of meter cube per minute. So here it is per second is given. So if you have not seen that previous video lecture, click on this link and understand the procedure, understand the steps how we have solved the previous numerical. And the second data is I have taken in a tabulated column. So outside condition is 30 degree and 75% relative humidity, and inside condition we need this condition. So triable temperature required is 22 degree and relative humidity required is 70%, and dew point temperature is given 14 degrees Celsius on the surface of the coil. And to achieve outdoor to indoor conditions, you need to follow cooling, dehumidification, and third one is heating. This is the condition he has given specifically in the numerical given data. Next, determine capacity of the cooling coil in tons, capacity of the heating coil in kilowatt, and amount of water vapor removed. Now we will write the equations for these three unknowns. Then we will come to know which data is given directly, which data is need to take from the psychrometric chart. And here capacity of the cooling coil first, that is equal to mass of air circulated. So this mass of air circulated can be calculated using density is equal to mass by volume. So mass will be the unknown, density is equal to 1 by specific volume, and volume of the air is given, and you can calculate mass of air easily. So H1 minus H2 is because cooling, the enthalpy drop takes place. So during cooling there is a decrease in enthalpy, so highest enthalpy minus lowest enthalpy. You can subtract and multiply with MA, you can calculate capacity. Similarly for capacity of heating coil and amount of water vapor removed. So to calculate these three unknowns, first I need to take H1, H2, H3 and omega 1 and omega 2. That is moisture content at point number 1, moisture content at point number 2. Okay. And dear students, one thing you remember, and here this is point number 1 condition. Outdoor condition, outside condition is point number 1, inside condition is point number 2. So the process taking place from point 1 to point 2, so between these two points, point 1 initial point 1 and final point 2, these three processes are there. So cooling, dehumidification and heating are the process between outside condition to inside condition. So now I will take one psychrometric chart. Here the psychrometric chart, and dry bulb temperature is here, and the moisture content is here, and these curved lines indicates the relative humidity. It is written here 40%, 50, 70, 90 like that, and on this scale you can take enthalpy values. Okay. Now first I will locate point number 1, that is outside condition, 30 degree and 75% relative humidity. So first I will locate point number 1. So 30 degree is the dry bulb temperature. Here is there dry bulb temperature, that is 25, and here is 30. And now I will take one more curve of 75%. Here it is 70% and here it is 90. Obviously this one will be 80. So this is 80% relative humidity curve line, and 70% is here. So if you take 75, that should be between these two. So this dotted curve line represents 75% relative humidity. And the intersection of these two, this curve line and this red color vertical line, I will take it as point number 1. This is outside condition, outdoor condition. So at this point I will measure enthalpy, that H1 is 82. This is 80 is the enthalpy here, this is 81 and 82. Okay. Next I will measure the moisture content at point number 1. So moisture content is 0.020. So this horizontal is almost on 0.020 line. So these three values I have measured here. Now I will look at inside conditions, that is required conditions. So 22 degrees Celsius dBT is the inside conditions. So take 22 degrees Celsius dry bulb temperature, draw one vertical line, and here 70% relative humidity is there. 70% is already available, the curve line. Here anyway I have shown with some dotted blue color lines. So here the intersection of this dotted blue color and this vertical red color line, I will take it as point number 2. Okay. So 70% relative humidity at point number 2 and 22 degrees Celsius dry bulb temperature. Here is the line RH value. Okay, 75%, 70%. So I will measure the enthalpy at point number 2 again. So take a scale, so draw an inclined line, 45-degree line, and touches to the enthalpy. So this is how we have to measure the enthalpy line. So don't take vertical or incline like that. The 45-degree parallel to these two lines. Okay, so here 53 is the enthalpy at point number 2, and unit of enthalpies will be kilojoule per kg. Next, now at point number 2 I will measure moisture content, that is omega 2. So point number 2 omega 2 value is 0.012. This value I have written here, and dear students, there will be slight variation in the values. So some students can take perfect values, some students there will be some slightly error will be there. Don't worry about it, but be careful when you are taking the values. Okay, using the scale you take the values of psychrometric properties. Next, as he mentioned in the question paper, first we need to do cooling, and understood. And here this is a outdoor condition, and this is indoor condition, that is inside or required condition. So between 1 and 2 you have to draw. So we cannot join 1 to 2 process, 1 to 2 line or 1 to 2 point directly. So if you join these 2 points, it will become cooling and dehumidification process. That is a single process, cooling and dehumidification. But in the given problem, he specifically clearly mentioned that first you need to do cooling, dehumidification, then heating. So we have to do first cooling process. So for that cooling process, what do you mean by cooling? Cooling is a process in which the temperature decreases, and the moisture content should remains constant. So here point number 1, I will start cooling process. So during cooling, temperature should decrease. So I have to go on the towards left, because temperature is 30. Here I have to go towards left. So to decrease the temperature, now I will take one heating process. Here is a cooling process. Okay, so during cooling process, the moisture content remains same. So cooling. So first process is over. Then second process is dehumidification process. So from this point to I will start dehumidification. So dehumidification process should be on this saturated line. You have to take this on saturated line only. So that is the reason I have not stopped cooling here or not stopped cooling here. So I have extended cooling from point number 1 to up to the saturation line. Here they have mentioned saturation temperature. This is the saturation line. Okay, so when this cooling line touches the saturation line, then from there the dehumidification starts. It will take up to here. Now you can ask question, why you have to stop here only, why you cannot proceed or not extend? Because the point number 2 is here only. Okay, now if you start from this point, okay, from this point I will start heating. Okay, this is dehumidification process up to here. Now I will start heating. So from this point to point number 2, it is heating process. Heating. Understood? Now I will list the properties at various points. So dry bulb temperature at point number 1 is 30. It is given. Similarly, dry bulb temperature at point number 2 is 22 degrees Celsius. This yellow color values box will show you the values at point number 1, and this pink color boxes values will show you the properties at point number 2. Okay, and the lastly we have written one more specific volume. This small v indicates the specific volume. I have taken at point number 1 only, that is 0.887. Why you have taken point number 1 only? The reason is he has given the volume of air circulated in the outdoor conditions. Okay, so he has given at point number 1. So here I have taken specific volume. So next, so this, the mixing of these two or intersection of these two lines I have taken it as point number 3. So if I ask you what is point number 3, point number 3 is beginning of heating process, or also it is called end of dehumidification process. Here is a dehumidification. Arrow mark is showing downward. So it starts from this point, it is coming and ending at point number 3. Now I will take the enthalpy at point number 3, that is 43. Here is 45, 46, 47, 48. So H3 is equal to 48 kilojoule per kg. Here is the value of unit of enthalpy. Okay. So next we will use some equations and we will calculate all the values. So step number 3 are written: mass of air circulated, MA, is equal to volume divided by specific volume. So volume, it is given in the numerical. So using this equation, density is equal to mass by volume. So I need to calculate mass. So volume will be go this side. So volume divided by specific volume. This is how the equation came. Okay. So volume is given as 3.33. Okay. That is meter cube per second. And 0.887 is a specific volume. We have taken from the psychrometric chart. The previous slide we have made on table. And there you have written 0.887. So you 3.33 divided by 0.887 will get 3.75 kg per second. How will you get kg per second? The reason is here it is meter cube per second and here it is meter cube per kg. Meter cube, meter cube get cancels. So the remaining is kg per second. And step number 4, the first unknown is what he has asked in the question paper is capacity of the cooling coil. That this equation you have written in the step number 1 or step number 2. Okay. So MA is equal to H1 minus H3. So mass of the air is 3.75 and H1 you have taken 82 and H3 is 48. So 82 minus 48 and multiply by 3.75, you will get 127.5 kilojoule per second. So this is the actual value of capacity of the cooling coil, but in the question paper specifically as asked in terms of ton of refrigeration. So to convert kilojoule per second to ton of refrigeration, you need to remember this correlation. The 3.5 kilojoule per second or 3.5 kilowatt. Joule per second is watt. So 3.5 kilojoule per second is 1 ton of refrigeration. So how much we got? 127.5. So this 127.5, so this much value of kilojoule per second is how much ton of refrigeration. Some 108.75 kilojoule per second ton of refrigeration is how much, but we need to calculate at 127.5. This is an example it has given. So if 3.5 kilojoule per second is 1 ton of refrigeration, what is the value of 127.5 kilojoule per second? How much is a ton of refrigeration? So you will get 36.4. Divide 127.5 divided by 3.5. 127.5 divided by 3.5, if you do, you will get 36.4 ton of refrigeration. Remember TOR stands for ton of refrigeration. It is a unit of refrigerating effect, that is cooling effect. So next, the next step what he has asked, capacity of the heating coil. So heating process is the third process what you have shown in the psychrometric chart. So that is 3 to 2. Okay, 3 is the starting point of heating and 2 is the end point of heating. So during heating process the enthalpy increases. So enthalpy at outlet will be more than enthalpy at inlet. So highest enthalpy I have taken first, H2, and minus lowest enthalpy. So H2 is 53 using the psychrometric chart. In the previous slide we discussed, and H3 is 48. So 53 minus 48, 3.75, obviously this is in kilowatt. So 18.75 kilojoule per second, that is also correct, or 18.75 kilowatt. And the last unknown what is at step number 6, the mass of water drained or removed during dehumidification process. So the dehumidification process, the mass of air, omega 1 minus omega 2 I will take. Omega 1 is the value at outdoor conditions. We can see in the psychrometric chart or previous slide. And omega 2 is end of the process. It is at point number 2, required condition. So omega 1, omega 2 values both we have done here, and subtract these two values, multiply with 3.75, and 0.031 kg per second is the value of mass of water removed. So what does that mean? For every second, if you remove 0.031 kg of water from the air, then you can achieve that those conditions what he has given in the numericals. So next, so step number 1, this value V is equal to 3.33 is given, that we have substituted here. Okay, thank you for watching this video. So in the next classes or next video lectures, we will post some more numerical on psychrometry, so with use of psychrometric chart. So thank you, take care, bye bye.